are starting 3.1. 3.1, we are going to talk about exponential functions today. That is an O. There we go. Exponential functions. All right. So to remind you what exponential functions look like, the basic exponential function is y equals ab to the x. It is an exponential function if the x is in the exponent. If you recall, back when we've done this in the past, this A is your starting point or your y-intercept. The B is either your growth or decay factor. If it is growth, B is greater than 1. If it is decay, B is between 0 and 1. So just to kind of remind you, a growth starts close to the x-axis and grows quickly. This is growth. This, of course, is your A value. If we have decay, decay starts big and gets small quickly until it gets closer and closer to the y-axis. This one is decay. And, of course, this value where it crosses the y-axis is the A value. Now, this follows the same wonderful translation stuff we've been doing forever, which, again, was a question on the test yesterday. Translation stuff we have been doing since the beginning of not beginning of last year, but October of last year. Okay, so if y equals ab to the x is my parent function, if I have x minus h in the exponent and I have plus k at the end, the h tells me whether I am going right or left. The k, of course, tells me whether I'm going up or down. And the A on the front is a stretch or compress. It is. So if it stretches, you think about it, if I stretch it up, that A moves up the y-axis. It's the y-intercept. It tells you how much you're stretching it. Same with if that A is negative, so A is less than 0, it's a flip. Which means this would flip over the x-axis, and your A would cross the y-axis underneath. Right? All those same things we were doing forever. So any questions so far? We're all good? Solid? Okay. So this is the foundation of what we're talking about today. Here is example number 1. At the start of your homework, 1 through 6, or 2 through 6 today. State if the function is exponential. And explain. So let's say I give you something as awesome as y equals 3 to the x. Is this exponential? Yes, it is. Why is it exponential? Perfect. X is in the exponent. That is absolutely perfect. Okay, let's try one more. What if I had y equals, oh gosh, how about 3x to the second? This would be no. And what would be our reason? Yeah, x is not in the exponent. Super easy first three problems, right? Okay. Example number 2. Example 2, we are going to do 7 through 10. Well, I guess this is 8 through 10 since I'm asking you to do evens today. 8 through 10, I want you to evaluate. It's going to hurt right here without a calculator. So maybe I give you something like y equals -2 times 3 to the x, and x equals, oh, let's go -2. We're going to just throw a hard one right in there at the beginning. Not even really hard. Okay, so this means I'm going to plug -2 in for my exponent, right? So I have -2 times 3 to the -2. A negative exponent does what? Moves to the bottom, exactly. Very good. So that means I have -2, and it's going to move this 3 to the bottom, and my exponent becomes positive. So one last thing to simplify, I can change that 3 squared into what? 9. Perfect. That's it. Okay. How about if I gave you, how about this one? Y equals, oh, let's go with, no, let's try, we'll change this. Let's say I have 3 to the x, and this time my x equals 2/3. So we have y equals 3 to the 2/3. Well, what does anybody remember about a fractional exponent? What does it mean? Oh, not quite. You're on the right track if I was solving. You're definitely on the right track. This means power over root. Exactly. So I can actually rewrite this as y equals 3 to the 2nd power inside a cube root. So this actually equals the cube root of 9. Do we remember the fractional exponents now? Do we need to talk more about them? Seriously? Okay, I'm just making sure because I want to clarify everything. All right. Let's go to example number 3 then. Trenton, put that away for now. Thank you. Nope. I need you focused here. You can focus on that later. All right. All right. 11 and 12. Let's, guys, find an exponential function for whoops, I meant to put x and f of x. My bad, sorry. And let's go with -2, 6, -1, 3, 0, 3/2, 1, 3/4, and 2 3/8. Okay, so to find an exponential function, we have a list 1 and a list 2. So I want you to grab your calculator or go into Stat. Go into Edit. This is list 1. This is list 2. Do I have what? So we type in list 1. You type in list 2. Then you go back into stats. Over to calculate. And down to exponential reg. Okay. Guys, focus. We should get y equals our a b to the x. Yes, you could get 1.5 times 0.5 to the x. Did everybody find exponential reg okay? Okay. Example number 4. As soon as I'm just waiting real quick. Example 4. This has to do with number 14. Find an exponential function given a y-intercept at 0, let's go with 0, 3, and a point at 2, 6. All right, so first of all, let's write what we know. We have y equals, my a is my y-intercept at 3, b to the x. So now I'm going to use my points, my x and y, plug in my x and y to solve for b. All right, so I have 6 equals 3, b to the second. To solve for b, what do I do next? Divide by 3 from both sides. So I get 2 equals b squared. Then what? Square root both sides. So I get b equals the square root of 2. Technically it's plus and minus. Because your decimal is rounding. It's actually less work just to leave it. Okay? So now, yeah. So now we're going to take our b and plug it back into our equation. So our final answer would be y equals 3 times square root 2 to the x. Any questions there? The what? Right here. This is my a value in the y-intercept. Okay, we're good? Do we need another one like this? Okay. Just checking. Example number 5. This and one more. So this is 16 through 24. Describe the transformation from f of x to g of x. And so maybe you are given something simple like f of x equals 2 to the x, and g of x equals 2 to the x minus 3 plus 5. All right. So in my exponent, I have x minus h. If I were to take that exponent set it equal to 0, this tells me that I have to move to the right 3 spots, or 3 units. My plus 5 on the end tells me I'm going what? Up 5. No, that too is your exponential, or your b value, whether or not it's a growth or decay. A is in front of that. So let me do one like that real quick. Let's say my f of x is, let's go 3 to the x, and my g of x is 2 times 3 to the x minus 7. Stretch 2, because that's the a value. And then what? Right 7. That's it. All right, now, in the book on these problems, it says to sketch the graph. You do not have to sketch the graph. Okay, I am telling you, you do not have to sketch the graph. Because what would you do normally if you needed to know what the graph looked like? You could graph it. So what point does it do for you to sketch it on your paper, right? I need you to be able to describe to me what's happening. That's the point. That's what the lesson's about, and so that's what I need from you. All right, so one last example and I'm done, okay? So this is what, 6? Example 6. Let's make it a tough one. Let's say I have f of x equals e to the x, and g of x equals negative 3 e to the x plus 2 minus 5. Okay, so we're describing the transformation between the two. Hey, listen. First thing we have is this minus sign, which means it's a what? Flip. Okay, then we have this 3. What is that? Stretch 3. Here we have x plus 2. What does that mean? Left 2. And we have minus 5. Down 5. Is there any question at all? E is an exponential function. If you look on your calculator on the left-hand side, in blue, right above the natural log, is e to the x. It is just, it's a function. It's an exponential function. E is in your calculator.